First law of thermodynamics. Before discussing the first law, let us discuss what is internal energy. Internal energy. Every substance is associated with definite amount of energy which is called as internal energy. Okay, so internal energy is the sum of various types of energies. Okay, sum of various types of energies. And internal energy is denoted by E or U. So E or U will be the sum of various types of energies like ET, that is translational energy, then ER, rotational energy, EV, vibrational energy, then bond energy, etc. Sum of all these energies are called as internal energy. Okay, now this internal energy is an extensive property. It's an extensive property and it is also a state function. Okay, so now in the case of ideal gases, internal energy is a function of temperature. Okay, it's a function of temperature. So, for an isothermal process involving this ideal gases, isothermal process involving ideal gases. In such a case, the temperature is a constant. Okay, so temperature is a constant means change in temperature will be equal to 0. So, delta E, change in internal energy will be 0. So, for an isothermal process involving ideal gases, temperature will be a constant. So, change in internal energy will be 0. Okay. Next, first law of thermodynamics. This law states the law of conservation of energy. Okay. Law of conservation of energy in different manner. Okay, so first law of thermodynamics explains the law of conservation energy in a different manner. So according to this first law, it states that when a quantity of one kind of energy disappears, an equivalent amount of energy appears in some other form. Okay, so this law states that whenever a quantity of one kind of energy disappears, whenever a quantity of one kind of energy disappears, an equivalent amount of energy appears in some other form. Okay. Okay. So, this energy can be, there are two modes of transference of energy. Okay. That is heat and work. There are two important modes of transference of energy, heat and work. Okay, so mathematically we can express this law of conservation energy or first law of thermodynamics as follows. According to the first law, delta E, change in internal energy will be equal to Q plus W. Delta E is change in internal energy, Q is heat change, and W is work done. Okay. Next, sign convention. First, if Q is positive or Q Q is greater than 0, which indicates the heat is absorbed by the system. Heat is absorbed by the system. Next, if Q is negative, that means Q is less than 0, which means that heat flows out of the system. Okay, heat flows out of the system. Next, what about W? W is positive. That is, W greater than 0 means work is done on the system. Okay, work is done on the system. Next, if W is negative, that means if it is less than 0 means work is done by the system. Okay, work is done by the system. Okay, there are special cases for the law of thermodynamics. What are the important cases, special cases of first law of thermodynamics? First case, cyclic process. In the case of cyclic process, we know change in internal energy is 0. Okay, that is dE will be equal to 0. So, from mathematical expression, dQ will be equal to minus dW. Okay. Second case, in an adiabatic process. Adiabatic process means adiabatic process. dQ will be equal to 0. There is no heat change. Okay. That means dE, from the mathematical expression, dE will be equal to dW. Next, third case. Isochoric process. In an isochoric process, dW is equal to 0. So, from mathematical expression, dQ will be equal to d. These are the special cases of first law of thermodynamics. Okay. So, example. A system gives out 20 joule of heat and does 40 joule of work. What is delta U? We have to calculate change in internal energy. So, according to the first law of thermodynamics, we know delta U or delta E will be equal to Q plus W. Next, sign convention. What about Q? A system gives out 20 joule of heat. That means Q will be a negative value. Okay, it is less than 0. So, minus 20 joule. Plus, what about work? And does 40 joule of work. That is, work is done by the system. So, the value will be a negative value. Answer will be minus 60 joule. This will be the answer. Okay.